Welcome back to another day. Today we're going to solve linear equations, systems of linear equations. What we do is we take two different linear equations, graph them on the same line, and see at what point do they cross. The point at which they cross is the solution. That's where they meet up. I'm going to talk more later on of why we do it. Both of these are in the form we want. In order to graph a line, we want it in the form of y equals mx plus b, slope-intercept form. The slope is m, the y-intercept is b. So let's graph these two lines and see where the solution is. The solution is the point at which they meet. So I put the two lines, y equals 2x plus 3 and y equals negative x plus 3. They're in the form that we want to graph. So I'm going to graph the first one. I'm going to start here. So I'm going to go up to 3. And then my slope is 2 over 1, so up 1, 2. Over 1, and I'm going to connect those lines and make that into a linear. There's the first one graphed. It's my first linear equation. Now I'm going to graph the second one. I'll do that in a different color, just so it's easier to see. I'm going to go back up to positive 3, and then I'm going to go, my slope is negative 1 over 1, down 1 over 1, and now I'm going to connect these. And I'm going to see at which point do these two lines cross. Where is it? I'll try to get the highlighter to work here. And as you can see, I'll get a different color. As you can see, the solution is where they meet and cross, and the solution to this problem is going to be 0, 3. What that means is this ordered pair would work in both of these linear equations. It would come out to be true in both of them. And that's the solution. Let's look at a different problem. If I gave you these two, the first thing is there's a problem. They're not in y equals mx plus b form, so we'd have to solve them and get them to where we want to get them. So quickly I'm going to start to solve these. And so what I end up with is 5y equals negative 4x plus 10. I divide by 5 on both sides. And what I end up with is y equals negative 4/5 x plus 2. That's going to be the first line I'm going to graph. Now I'm going to have to do it over here. Subtract 3x from both sides. Subtract 3x from both sides. I end up with negative 3y equals negative 3x plus 21. Divide everything by negative 3. And I end up with y equals 1x, or just x, minus 7. So here's my two lines. I'm now going to graph those two and see at which point do they meet up. So, going over here to my graph, y equals negative 4/5 plus 2. Y equals negative 4/5 plus 2. And I can graph this now. Go up to positive 2. My slope is negative 4/5, so I go down 4. 1, 2, 3, 4 over 5. 1, 2, 3, 4, 5. Connect those two lines as best I can. And now I'm going to graph my other line, which was y equals x minus 7. I'm going to go back. Y equals x minus 7. My y-intercept is negative 7. My slope is 1, 1. I'm going to connect these lines and see where they intersect. That is the solution to this. See if I can get this to go straight. That's not too good of a line, but we're going to work with it. I can see, though, if my line would have been straight through those points, I know that the solution would have been right here, which, what is that ordered pair? It's going to be 5, negative 2. That is the solution to this system of equations. If I was to put that into both of these, it would work out to be true. Let's have you do a problem. Y equals x and y equals negative 2x. I want you to graph those two lines, find out where they cross, and find out the solution.